here, which is a little pointery program. Okay, I've got an array of 10 integers. How many bytes? 40. Okay. And iArray, that word, the compiler will treat like a pointer to the first of those 40 bytes. Okay, but that's the compiler treating it. It's not really a pointer. The compiler treats it as one. That one is a pointer, IP. How many bytes is that? 8. On our machines. Could be 4, but it is 8. And then we got a nice little int. That's 4. Okay. Go through a for loop, set the values in iArray to 100 to 109. Okay, nothing fancy about that loop. Okay, and then I print out the pointer of where iArray is. Okay. Again, that's going to be the pointer location of the first of those 40 bytes. So that's where you find iArray 0 is at that pointer. What do we know about that pointer? I don't know if I heard someone say it. There's something we know about that pointer. When I print it out in hexadecimal, what am I going to see?
Be a line of 4 bytes?
Yes, it'll be a multiple of 4. It'll be a line of 4 bytes, so it will end with either 0, 4, 8, or C. Guaranteed. Okay, now I set the pointer to iArray. So now we have 2 things pointing to the same thing. Okay? And then I go through a loop and I print out 5 quantities. Okay? I. That's easy. Right? Number from 0 to 9. Then I print out iArray I. That's going to be a number from 100 to 109. Again, nothing exciting there. That we set it right here. Okay. Now it's going to print out the pointer IP. Okay. Well, what ends up happening at the bottom of this loop? IP gets incremented. Now, when I increment a pointer, what it does is it's going to move it up 1 value. An integer is 4 bytes, so this pointer is actually going to change by 4 because it's got to point to the next integer. Right? So this IP moves the pointer up 1 value, but that's going to take the pointer's index value and move it up by 4. So now this is going to start. So IP will start by equaling, I don't know if that's 1 or 2 L's, iArray, but will it will increment by 4 each time. Now I'm going to print out star IP, which is what IP is pointing to. Well, first, IP is pointing to the 0th element of iArray, and then when we increment it, it's pointing to the first, and then we increment it, it's pointing to the next, etc. So this will be number from 100 to 109. And then lastly, I print out IP minus iArray. That's pointer arithmetic too. Okay? What that's going to do is that's going to say, much like when I do this, it increments the pointer by 4 because it's incrementing it by 1 integer. This is going to tell the number of integers between IP and iArray. Okay? So even though the pointer values may differ by 4, if they differ by 4, then that's going to return 1 because that's 1 integer. Okay? So this will be number from 0 to 9. Okay, let's see if I'm lying. So we'll go. What is this? Is pointer. There we go. You don't need to see that. And then let's say make bin iPointer. Make bin iPointer. Oh, I said IP. Okay. All right, no warnings. That's nice. Let's run it. All right, so first, pointer, got a big yucky number. I didn't lie. It's a multiple of 4, right? It's 0. Then, every one of these should be as we expect, right? I is a number from 0 to 9. iArray is a number from 100 to 109. IP starts by equaling iArray, but it's going to increment by 4, right? 0, 4, 8, C, 0, 4. This is why hex is nice. You wouldn't be able to see this if you weren't looking at it in hex. Okay. Star IP is pointing to the same thing as iArray, so that's going to go from 100 to 109. And then when I do the pointer arithmetic, this is working in units of ints. So there's 1 int here, 2 ints here, 3 ints here. Okay? I know pointer arithmetic confuses you. When you look at it like this, you're probably like, oh, that was pretty simple, Dr. Plank. That makes sense. And then when you put it into context later in the world, you're going to be like, I have no idea what's going on. I understand. That's the way life is. Okay. But that's why I keep going, to try to keep helping you with this. Now, in successive programs, which I am not going to go over, but they're in the lecture notes, and you can go over them if you pull the lecture notes as a Git repo. I have the very exact same code here, only now it's a char instead of an int, okay? Which means that pretty much nothing changes here except for these values now differ by 1 instead of differing by 4. Okay, so there it is. Right, and you'll note it didn't have to start off a line because it was a char. Right? I think I do the same thing with doubles. Do I have a double one? Yep. D pointer. Exact same things, right? So now what's going to happen? Well, we know this pointer is going to be a multiple of 0 or 8, and now here it's going to go up by 8 each time. Yep. And it's printing it out as a double now. And then the last one, what do I call it? SPTR. Now what I do is I have a struct of 2 doubles. Okay, so the size of this struct is 16. Everything else is the same. I print it out a little bit different, but everything else is the same. I also initialize, here I initialize one double to 100 to 109. This double I'm doing from 200 to 209. Okay, but I do pretty much the same thing. I print out both here and both here. But besides that, everything's going to look the same. Even these subtractions are going to look the same. When I print this pointer, its value is going to now differ by 16 each time. Okay? Is it going to be a multiple of what? It'll be a multiple of 8. Okay? And the reason it's a multiple of 8 is because it needs its first data type to be aligned. And the first data type could be a double. It is. Okay, so when I run this, you see all the same stuff, except I have 2 numbers in there. And you'll see, right, that's now going up by 16 each time. Okay. I have this thing called Little Quiz. Where is Little Quiz? Little Quiz. There it is. It's kind of big. All right. This is an example of a quiz question that I might ask. Let me just preface it with this is an easy quiz question. Like when I look at this, I think this is a pretty simple quiz question. It's not very convoluted, but it is of the ilk that you will see probably on your midterm, kind of questions like it on that little quiz that you'll take on Friday. Okay. So here's the quiz. Got a piece of code, and then I say, here's the first output. Here's the first line of output. I give it to you. Can you see that? Do I need to scroll it? Okay. And then I say, what is the rest of the output? Okay, so let's first take a look at what's going on. Same as before, I've got an array of 10 integers. I've got a pointer to it with IP. I've got another pointer called A1. I got a pointer to a pointer in IPP. I set IP to point to I. So it's not pointing to array, it's pointing to I. I have IPP pointing to IP. And then I have A1 pointing to the first element in array. Okay? I go ahead and I stuff the value I into array sub I. And I set I to 11. Should be there anyway. No, it was 10 before. And then I do this print statement here, which prints right down here. So I've got these are nice 32-bit pointers, right? So E, F, 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 9, F, C, et cetera, et cetera. Okay. And so what am I printing? I'm printing IP, which is a pointer to I. So this is going to be where I's bytes are in memory. the 4 bytes that we have reserved for I, that's going to be in that memory address. Ampersand IP, which also equals IPP, that's where this is a 32-bit machine, that's where the 4 bytes for the pointer IP are stored. Okay? And then array, well, that's going to be a pointer to the first byte of those 40 bytes. Okay? So when you do something like this, it's a good idea to kind of draw out memory and fill it in. Okay, so if we look at these addresses, we've got, let's just ignore the EFFFFs, and we can go 9, and it looks like the smallest of those is 9CC. So what I'll do is I'll start with 9CC, and then the next address will be 9D0. There we go. Whoop. 4, 8, C. I'm going to do these in units of 4. Right, and then here, and here let's do 4 more. I don't know how many I'm going to need. All right, think I'm going to need more? I need 40 bytes. I'll do one more set. All right, so 9F, A0. Okay, so address, value. Okay, and let me go ahead and get myself some spaces here for my values. Okay, so now what do I know? All right, I know that the value of the pointer to IP is, or the address of IP is 9CC. Right, so right here, let's go ahead and give ourselves some spaces here too. Right, this is 9CC is the address of IP. Is sitting there. So what this is this value is going to be IP. And we've printed that out, right? That's 0xEFFFF9FC. Bigger so our wraparound doesn't kill us. Okay, and now here we have IP. We know its value is 9FC. What is sitting at 9FC? Well, that is the address of I. All right, and what is I? I is 11. So the value here is I, which is 11. And then here we have array is 9D0. So what we know here is this is basically A0, all right, and that's going to be A1, A2, etc. And so we know what's sitting in there is what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Do we know where IPP is stored? The answer is no, we don't, because we haven't printed it out. We know what its value is, right? Its value is F9CC, but we actually don't know where it's stored. Okay. What's the value of A1? Well, A1 is pointing to array sub 1, which is right up there. So the value of A1 is going to be 0xEFFFF9D4. All right, so now what's the rest of the output? Well, the first thing we do is we print ampersand I. I mean, that one we didn't need to do jack for. We know what ampersand I is. It's equal to IP, and we printed out IP. So that's good. So the output now is going to be ampersand I, 0xEFFFF, 9FC. Now it says print out the value of IPP. So now what I do is I print out the value of IPP. What does it point to? What does that point to? When I do crap like this, I don't put tricks in here. I don't say IPP and then put something else over here. That would just be cruel, and I would never do that. Okay, so we know what IPP is. IPP, we printed it out, didn't we? We printed out ampersand IP. So we're going to get IPP is 0xEFFFF9cc. What does it point to? Well, let's just look. We see it. It's right there. That's what it points to. So star IPP is that. What does that point to? Well, 9FC. We know what that's in that. It's 11. We don't have to think very hard with that. Once we look at memory, we can see what's there. 11. Okay. Now, let's do gross stuff. Okay. I now add 4 to A1. What's that going to do to the pointer? It's going to add 16 to it, right? Because it's going to move forward 4 values. Each value is 4 bytes. So now my value of A1 is 9E4. Okay? I go ahead and set that to 500. So now 9E4 is here. So now that's 500 instead of 5. And then I go ahead and I print out everything in the array. So that's going to print out 0, 1, 2, 3, 4, 500, 6, 7, 8, 9. Done. Okay? I'm going to give you practice on these. Okay? I'm going to give you practice. But this is a skill of this class, is being able to navigate memory, being able to interoperate between ints and chars and doubles, and strings with what the implication is of big endian, little endian on that. We're going to live in a little endian world, okay? But our strings are printed out serially. So in fact, on a big endian machine, your strings when you turn them to integers, go differently. Okay? So we're going to go through all of that stuff. All right. Early click. When's class over? Not forever, right? 2:10. Prepared enough material? We'll see. That went quick. Is there more? No. It's in the lecture notes. All right, let's go ahead. Now's not a bad time. Let's do a clicker. I'm sure what's in the clicker.